Well, hi. I hope you guys are all doing okay and managing to get through this very strange time without too many issues. You may have noticed if you checked the web page I have for my classes that I've updated every other class but not math analysis. And you may have been wondering just what are we going to be doing next? Of course, back during the basketball tournaments, we were looking at some problems with exponents, and I did put a little quiz about that up on the web page. But I've honestly been spending a lot of time this past week trying to think of what would most naturally work to do online with you. And eventually I did make a decision. What we're going to do is what I usually do last in this class each year, and well, it may end up being the last thing we do this year too, we'll have to see. It's what's called Chapter Zero, and that may seem like kind of an odd name. The name actually comes from the name of the first chapter in one of the books we use for calculus. Many of you will be in that class next year, and even if you're not, this should give you a good background for a lot of things going forward. Now, very naturally, you may be asking, so why are we doing this, or what's the point, or what exactly are we going to cover in Chapter Zero? Well, basically, the goal of this is to review everything that we've done this year. You might have noticed when I had the page from the book up there earlier, it said functions on it, and that's what an awful lot of what we've done this year was. It also will end up reviewing everything that you've done before in math. And in the process, you're going to learn some new things as well. For those of you that are going into calculus, it'll be useful there, but it's also useful in almost every college math class, and a lot of the things that we learn here could be useful on things like the ACT. Now at this point, I know none of you are going to be taking the ACT in April because they canceled the ACT nationwide, but some of you may be doing it in June, or you may be retaking the test next year, and having a little bit more background on that can only be a good thing. The first topic we're going to look at combines review with a little bit of stuff that's completely new. And the topic is graphing and interval notation. You should remember from Algebra 1 or even from junior high how to graph on a number line. I know most of you have done that because you did it that summer after your 8th grade year when I taught a lot of you in Algebra 1. You should know things like if it's greater than or equal to, you put a solid dot to show you include the number. If it's just greater than, then you put a circle there to show that it's open. If it's greater, you graph to the right. If it's less, you graph to the left. And I'm betting I could give you 100 of these problems and you'd get all of them right. While you didn't do as many of them, you should also remember problems that look like this, where your answer is what's between certain numbers. You still use the dots and the circles to show whether you include the endpoints or not, but you're looking at numbers that are between one thing and another rather than just greater than 1 or less than 1. Those graphs that we looked at on the previous screen are called intervals, and interval notation is just another way that you can write inequalities. We're used to using less than or greater than, less than or equal to, greater than or equal to when you write inequalities, but interval notation instead uses parentheses and square brackets to communicate the same information. You'll see things that look like what I have at the bottom where it says parentheses 3 comma 7 bracket. And that means the exact same thing as everything between 3 and 7, not including 3, but including 7. When you use parentheses in interval notation, it means you don't include the endpoints. So here I have the interval -2, 4 with parentheses around it. That means I want all the stuff between -2 and 4, but not those two endpoints. Now, when you see this in the problems we're doing now, it will typically mean an interval It doesn't mean the point -2, 4. You have to tell that from the context of the problem, but in this section we're going to be looking at intervals, and that will mean graph all the stuff between -2 and 4. If you put square brackets around the numbers, it means you do include the endpoints. So brackets -3, 1, that means that I want all the numbers starting with -3 and going all the way to 1, including those endpoints. So here's a couple of problems that are asking you to graph these. I want you to at least think about what the graph will look like. I'll give you a few seconds here and then we'll look at the answers. So this first one, it's got parentheses on the left and it's got brackets on the right. That means I don't include -6, but I do include -2, and I want to have all the stuff between it. Would be exactly the same as saying -6 is less than x, which is less than or equal to -2. If you think about what the symbols mean on the other one, it should kind of make sense that this really is just a fancy way of saying x is greater than 2. It's saying we're going from 2 to infinity. And you don't include 2, so that's why I have a circle there, but I do go on forever. Whenever you see infinity in interval problems, it'll always have parentheses with it. That's because infinity isn't exactly a number, so you can't say that you include it. You just keep going. And here's the same sort of thing backwards. It's almost like you're playing Jeopardy. See if you can think what intervals we would have here. So it should kind of make sense that the first one's going to include infinity again, and since it goes to the left, that's why I put negative infinity. It goes all the way to 0, and since I do include 0, we put a square bracket there. So parentheses, negative infinity, comma 0, and then square bracket. The numbers involved on the bottom are -4 and 4. I do include -4. I don't include +4, so that's why I have square brackets on the left, parentheses on the right. Now, if you were going to school in Europe, where, by the way, the schools are also closed at the moment, they actually use interval notation with parentheses and brackets on the number line itself, not just when they're writing out the expressions for it. I've had exchange students here over the years where it took them a while to get used to using circles and dots because they were used to using brackets and parentheses. Most of this section that we're going to be looking at today deals with functions, and the majority of it is review from stuff you've done as far back as Algebra 1 and as recently as this year. When I post this, I'll be posting a worksheet that you really do want to go through and do the problems on, and eventually I'll put answers to that you can look online and compare as well. Some of the questions that you'll have will simply ask you whether or not things are functions. Remember, the way that you can tell that is by using what we call the vertical line test. If you ever have a vertical line, an up and down line that would touch the graph twice, it is not a function. If every vertical line just touches once, then yeah, it is a function. You'll also be asked to evaluate functions. Here's 3 problems that you can use as examples of that. Let's just take a minute and see if you can come up with the answers to these. So I just did these straight off on my calculator, and there's no reason why you can't do that too. If you don't have a graphing calculator, I put a couple of links on the webpage to where you might be able to download one. And even if you don't have a graphing calculator, you should be able to use the calculator on your phone to come up with answers as well. Couple of things to remember when you're evaluating functions. First off, when you have x in more than one place, you have to substitute in more than one place. And the other thing is always remember if you're working with negative numbers, and especially if you take them to powers, you want to make sure you put them in parentheses. You can just kind of think through on that last one that 3 times negative 2 squared would be 3 times 4, which so far is 12, and then you have minus 2 times negative 2, that's 12 plus 4, which is 16. Something that's easy but people don't always know how to do are problems like this where you're given a graph and it asks you to find different values of x. Let's see if you can figure out what this would be first. So it really is easy because all they're asking you to do is figure out what's the y value first when x is 1 and then when x is negative 2. If you look on the graph when x is 1, the y value that goes with that is negative 3. And if you go over to negative 2, it touches the x-axis, so that's why the y value has to be 0. Again, if it just says find f of some number, you want to know what's the y at that number. Something you did both last year in trig class and also earlier this year was finding domains of functions. It's not hard, but people often forget what you're supposed to do with that. Again, we'll let you stare at it for just a minute and then we'll talk about how to do them. So these two problems cover the two things that can go wrong when you are working with functions. If you don't have a fraction and you don't have a root, then the answer would just be all real numbers. Here, though, we have a fraction, and the important thing is you can't have 0 on the bottom of a fraction. And what you need to do is ask yourself what would make the denominator 0? What couldn't you plug in on the bottom? Well, here, x can't be 2 because 2 minus 2 is 0. And back in trig class, I just had you write the answer as x is not equal to 2. What most advanced math books, most like college texts would do is they would write the answer in interval notation. And here we're saying you can go from negative infinity to 2 and you can go from 2 to infinity, but we put the parentheses around 2 to show you can't have that. You could also write x is less than 2 and x is greater than 2, but it's not 2. When you have a square root, what's important is that you can't have negatives under the square root or else you'd have a complex number answer. And so here, what's under the square root is x plus 5. I know that has to be greater than or equal to 0. You solve that, you get x is greater than or equal to negative 5. I certainly accept x is greater than or equal to negative 5 for an answer. A book would typically write that as negative 5 to infinity. Again, those basically are just different ways to say the same thing. So these are also some easy questions. It's asking you whether certain points are on the graphs of certain functions. Again, we'll just kind of have you think about what would you do to figure that out. Well, the key to this is really that f of x is just a fancy name for y, So what you want to do is put in the number they give you for x and see if you get the y that's there for the answer. And here, if you do take 4 times 3 minus 7, yeah, we do get 5, so yes, that point's got to be on the graph. On the other hand, if I plug in negative 2 into this function, we end up with 4 minus 2 plus 5, which ends up being 7, and that is not the same as the 3 that's in the point, so that's why the point isn't on the function. Now there's actually a couple of other things we're going to work with functions as well, but we're going to save those for the next set of stuff we're doing. For now, I want you to get some practice working with these things, and next week's quiz will involve just the basic stuff with functions that we've gone over in this video. So good luck, keep yourselves healthy, and enjoy yourselves while you're away.